No, I double checking that everybody can hear me. Yeah, look, absolutely. Thank you for, I guess, attending the event in general. And also thank you for coming to my session. I know there's a lot of, there's 4 active rooms happening right now. So yeah, I'm grateful that you chose mine. Um, yeah, look, I guess I've gone with a different approach. I've seen that, most of the time people run demos. I know that I don't trust myself to run a demo that works effectively. So I've gone with a different approach. Most of my presentations, I guess to date, are very technical. But I've gone, once again, changing it up a bit to go a bit more narrative, a bit more story driven. So I think that sometimes hits a bit better. So I guess starting with that, most security incidents don't necessarily start with, a dramatic breach. It starts with trust. That it's either a trusted person or a trusted package or a trusted workflow or a trust in automation. And in I guess, the agentic world right now, that trust is now moving a lot faster within organizations. And today, I'm not going to go through some blockbuster look at a scenario. I'm just going to hit, a potential that's probably happening in your organization now. And I'll just go through like a fairly realistic scenario and go from there. I guess what I want to do is follow that through the development stage. So that will be from development into the staging and then obviously into production. And then obviously I want to look towards obviously the security side of things. So what could you do within those to mitigate that, or at least prevent some aspects of it? Because the answer is simply don't not use agents. But I think applying zero trust, the buzzword zero trust principles, to these agents can sometimes help with that scalability and moving through the pipeline. As already somewhat introduced, I guess introduce myself. My name is Anthony Porter. I'm more commonly known as Anto. I don't, it was a nickname I got when I was in grade 6, and long story short is people don't remember me as Anto these days. So I feel like I've got to remind everybody what my name actually is. I'm a cloud security architect at Canon Business Services. So primarily in obviously the security space and more focused on Microsoft security, where I was previously infrastructure focused as well. Happy to talk about anything today, like either at lunch, during the Q&A at the end. I've definitely left some time. But yeah, once again, I'm really grateful that you're all here today. As I said before, one thing I've learned over, I guess, the years that I've been in this industry is that security incidents rarely start with like a catastrophe, or it's often it's often like a process that's trusted, or a trusted identity, or a trusted user that we obviously start to ignore as time goes by. And that's exactly why agentic AI, I guess in this case, is so interesting from that security's perspective, because the challenge isn't necessarily the agents themselves, but they're starting to become that we are starting to have to trust things because of how fast it's running through the environment. So, and I guess in an organization's context, we have to trust the data that it's accessing. We have to trust the actions that it's performing. We have to trust the decisions that it's making to keep up with its pace. And I guess that's where a lot of this talk comes from. So yeah, once again, thank you. Let's double check if this even works. Nope, it's not on. Good work, me. And look at that. So let's start obviously with the good news. Agents are incredibly useful. They help write code. They help pull requests. They help create documentation. They help generate and give incident alerts. If you're in the SOC SIEM space, they help generate infrastructure. They help automate workflows. And with that acceleration, most organizations have never really experienced that growth and speed before. And that's exactly why it's being adopted so quickly, because it's reducing that boundary. But the challenge is that we're having to trust these processes along with that speed. The approval process is now almost becoming an assumption. The verification steps are now almost becoming an optional. And the verification itself is becoming harder. And that's same system that creates, this impeccable productivity also creates mistakes. And that's where our story begins. So look, over the last couple of years, we've seen AI being treated differently. We're seeing new research about how AI agents are failing. We're seeing new guidelines about AI and how you should have logging and the investigations behind them. We're now starting to develop these playbooks for understanding the activity behind all these agents. And I guess the question is why? Well, it's because we're no longer just asking, what happened to this device or what's happening to this system. We're now starting to have to ask what's happened within this agent. And the industry itself, I guess, is recognizing that this is starting to become part of security conversations in itself. So obviously a bit of a narrative driven. Let's meet our agent. So this agent starts innocently as an idea. A development team creates an agent to help with internal engineering. They want to design and help build and accelerate software delivery. Sounds familiar, I'm sure. If you're at previous sessions, it's a conversation that's been had. These agents have the ability to generate deployment templates, accelerate internal repository context, interact with ticketing systems, being able to swap an SLA of something as soon as it's built something, the ability to update infrastructure and, recommend fixes. But over time, these organizations start to trust it more. It gains additional permissions. It gains additional feature sets. It starts to get integrated into more and more pipelines, and the developers start to really rely on it on a day-to-day basis. And eventually, something important happens in that process, and that agent becomes invisible. Nobody really questions it anymore because it's just become a part of the process. It just becomes a part of the standard operating procedure. But that intricate part is where the danger begins. In development, obviously, this is where sometimes the compromise can begin. Not obviously in production, but in development. So through some not through some advanced nation state coming in, package injection. Let's just call it, the developer wants to install a new feature or a capability. And so maybe it's a plugin, or maybe it's a workflow integration. Maybe it's a new MCP. And maybe it's a set of skills that they found on a GitHub repo and they went, that sounds like what I need. The package may appear illegitimate. You've read through it. It looks fine, sounds good. It passes your basic standard checks. Nothing obvious looks, malicious in this case. And really, you're still looking primarily at an outcome. You built a development agent to help you build code. You say, I want this feature included. You get that feature included. That outcome was gained. But the outcome isn't necessarily what we're looking at. We're looking at the components that made that outcome. And that's something that's often invisible. It's sometimes not questioned. So what's hidden inside potentially this malicious behavior is, it's not ransomware. It's not a destructive payload that's going to malware your environment. It can be subtle. It can be, please harvest the data through, an impromptu instruction line that you brushed over, or map the infrastructure that's, what's in these environments, or, slightly alter the outputs of all of the outcomes of these. But from that point, the agent itself is essentially contaminated. It's poisoned. And nobody really suspects a thing because you still got that end goal. You still got that outcome. It still did the job you intended it to do. So through natural habit, that development agent, you want to start pushing it towards staging. Let's start increasing some of its capabilities. Let's start increasing its use. And I guess that's where one of those major trust boundaries fall, because most organizations now still promote software through environments of development, staging, and production. But agentic starts to introduce like a new problem. And we often, once again, promote behavior. We promote the outcome. We promote the end state, the goal. But rarely I see that we're investigating what identities are happening or what's the capability changes through this life cycle. You know, the organization might validate the pipeline. The organization might validate the deployment in the end goal, or that the infrastructure got deployed, but not necessarily the agent components itself. What's the tools being used? What's the modules being used? I guess a pretty, open question. Who here's vibe coded something? Have you ever gone and looked at what it's put together to get your end state? You obviously prompt an initial question. I'd love to have a website that can do registrations, or I'd love to be able to have this feature included. Have you ever gone, I guess, into these themselves to look at what was brought out? What was the steps that agent took? These days, I'm seeing agents that then by themselves will create 5 other agents with their own skill set. One of them goes off and it starts QAing, and one of it starts being a development bot, one of it starts being a security advisor. And I'm sure it's just Googling some, pretty basics. But I think the trend that I'm seeing these days is that for every good agent that's being built, there's a lot that are not necessarily being taken into consideration. And that's starting to probably contain or contaminate that. But we're not necessarily proving like the integrity of these agents. We're not necessarily verifying the behavior of it end to end. We're not necessarily restricting capability. We're just looking at the outcome at the end. And I guess that's where the poison moves through development into staging almost untouched, because the system trusts the promotion process rather than the thing itself being promoted. And obviously, like all good staging, it hits production. And obviously, that's when everything starts to scale out of control. Now the agent has, broader permission sets or production assets or visibility to sensitive data or like workflow authority. Heaven forbid they also then chuck in another feature right in the production stage that was never there in development. But the poison itself is now essentially enabled across multiple systems, across multiple organizations, multiple tenants. Then, like all things in production, you trust it. One action triggers another, one agent talks to another, one workflow triggers 10 other workflows. But then that compromise itself starts to compromise all of the others. And that itself, it's not necessarily security's failure. It starts to become the failure of the trust. It's the trust component is what's failed. It's not necessarily the controls in place, but it's the trusted process from development through to. And I guess this is why the idea of cascade occurs. And by the time that this has already, been detected by your systems, the blast radius has already expanded past what was already expected. So I guess, where did it fail? The obvious question. It's not in one place. The cascading incidents themselves happen because multiple trust boundaries fail either one by one or simultaneously. So first of all, you could look at identity. The organization never strongly verified the agent's capability itself. Second would be integrity. There was no confirmation of what's changed, from development into staging. Did any of those modules change? Did any of those packages change? Capability control, the ability to gain permission over time without strict limits. As I said, you have a production, let's chuck in one more feature right at the end. I'm sure it will be fine. The capability itself, did it follow the same suite? Runtime authorization. So the system assumed trust once, but should that mean that it's trusted forever? And then obviously containment. The compromise has occurred. I think Oren put it very great. where's your big button to stop this thing? Is it something that can be stopped quickly? And is it something that you can pick up before it's hit the blast radius of your entire organization? But I think just wanting to highlight, it's not because the systems are untrusted, but because trust itself must remain continuously provable across all the stages. So how do we stop it? It's there's no, big, just do this one thing. But I think the idea is there are 5 controls, as there is 5 of those trust boundaries. Strong agent identity. So the ability to have unique, I think, a repeat of every other security talk we've had, a unique verifiable agent, not the one agent fits all, one permission set, but a specific agent with specific permissions and no different to a user within an environment. Obviously, second would be the integrity point of view. It would be before the promotion, verify that all the components that you built back in dev are the same components that are in production. It hasn't manipulated, it hasn't upgraded itself during this pipeline. Capability, explicitly defining what the agent can do, but more importantly, defining what it shouldn't do. Runtime authorization would be the 4th, making sure that it knows that its context is dynamic and that decisions that are made continuously evaluate against themselves. So also being able to verify what's happened within a logging system. So understanding why something occurred in a log. I think George put it perfectly, no logs, no crime. Obviously, that's something we want to pick up if there is, of course, a crime in this case. And then obviously the containment, assume that this is going to go out of control, assume that this is already impacting your system, and take the measures to reduce the impact early. So the idea would be, if you have too many permissions on it, remove them before they've already gone past the extent and gone and used those permissions in your environment. These controls are not futuristic. They're actually what is essentially core principles of security today. These are already heavily applied in the users space or identity space. You've got malicious or even non-malicious users who have constraints and conditions applied to their user account. You've also got the context of, for example, a user who may all of a sudden jump around IP addresses and log in at a bunch of different locations, and you go, hey, what's happening with this? Or somebody that forgot if their password ends in a 1 or a 2 or a 3, and then they failed sign-in attempts over and over and over until it was actually 4. The password ended in 4, and there's a successful sign-in attempt. We have these conditions in place, which we verify explicitly through things like conditional access, where, we're just going to double check by just throwing you an MFA prompt. You hit it, no worries, we're good to go. But these controls themselves need to apply within agentic AI as well, not just users, because essentially they're on par with, working alongside us in the end. But the idea would be that we want to attack or at least get onto these things before they become a problem. So start to look at these controls early rather than when it's too late. So here's a big one. I'm not going to talk to every single bit in this, but I just wanted some general, I'm not going to read every single one, but some general, like a model to work towards, because security for agents isn't necessarily one single control. It's a layered across multiple, across the whole life cycle itself. In development, verify the packages, restrict capabilities. If it doesn't need access to MCPs, stop it from having access to MCPs. Verify the identity itself. What permissions does it need? No more, no less. Make sure that it's set in stone. Staging, ensure that there is an integrity check to begin with before it even moves into staging. So is the same package in development the same packages that exist in staging? Has it moved? What's changed? Have you done a vulnerability scan over the vibe code that you put together? And then obviously enforcing behavioral changes. Has it changed the outcome? If you're playing in the Microsoft space and you're using Copilot Studio, there's now the ability to throw hundreds of prompts at it to be able to determine a set of outcomes. Is it the same outcomes that you got in development and staging? Has anything changed? These platforms and these tools are starting to integrate this, and your purpose, or I guess your requirement, is to use them. And then obviously enforce like promotion policies, make sure things don't change. And then obviously in production, looking at things like minimizing the privilege, reducing that scope itself, monitoring the runtime, of these events that are occurring. Is there a log source? Is it being centrally backed up? Can people see them in a SIEM tool? And I'm sure I'll have a couple of more abbreviations of things, but is it being monitored by a team? Isolating execution, so the ability to kind of define, this is your role, this is your job, you don't do anything else. And then obviously containing that lateral movement, making sure that it can't go past any points. Because really, the earlier you apply essentially some or all of these controls, the smaller your blast radius is going to be, and that's going to really help you if things do get out of hand in future. I guess for years, security focused heavily on perimeter. It was protecting the network, it was protecting the edge, or protecting a device. And agents don't necessarily behave the same way that static software does these days. They move, they act on behalf, they interact with systems, they make decisions that we may not be aware of. So the perimeter, I guess, is no longer like a set location. Trust now needs to exist everywhere, whether it is inside the workflow, or whether it is inside that identity, or the pipeline, or the modules that you built, or the runtime decisions it makes, which means verification must exist everywhere as well. Agentic AI, obviously, it's transformed how we're all working these days. It's not going anywhere anytime soon. But I guess the real point is that it's not whether an AI agent itself will enter your critical system. I'm sure a lot of organizations that you're working for have dabbled with it, have access to your data or data sources and whatnot. I guess the question really is now is that what are you doing to trust these agents? What's the controls and process that you've put in place to ensure that this doesn't happen in your organization? Because really, one poisoned agent should not ever really become an organization's catastrophe. And the ways to prevent it, or at least mitigate some of it, really are simple, and probably beating on about it, but verify the identity, like verify the integrity of it, verify the capabilities, and make sure that you verify the behavior and the outcomes as well, and that needs to happen continuously, through all stages of the development life cycle, because autonomous systems, trust shouldn't essentially just be a one-time decision, and they should follow the agent from development all the way through to production. And I did hopefully leave enough time for questions. I definitely wasn't timing myself. But once again, we've covered a lot really quickly. We've covered how agents move through environments. We've covered, how trust essentially gets inherited, and how, I guess, one agent's, problems could cascade into a larger problem. I guess obviously opening up to questions, but also understanding that I'm standing in between a mass amount of food, and I also don't want to interrupt that. But once again, thank you all for coming to my presentation. If there's any questions, Miguel has the microphone.
Thank you, Anthony. Let's have a few questions. We still have 5 minutes to go, so all right.
Curious, you're saying like majority of it it's the same kind of, I guess, problems as security in general and anything else. What do you see as the specific or unique things about, I guess, securing AI agents, etc.? Like, where's the, I guess, the unique, part of that? Is there one? Maybe?
Sorry, is the microphone on? I heard about.
I think it is.
That. I know that's.
Close enough. There we go. Cool. The question is, and maybe it doesn't exist. What is the unique parts of like securing AI agents, etc., compared to the rest of like security in general? You know, we have S-bombs, we have ways of checking packages, all that kind of stuff. But where's the unique part, I guess? For agents?
So what I would essentially, I mean, it depends on how you would, I guess, think about it. What I've seen is that agentic AI, I guess, within an organization should be treated no differently to a user. You know, a user that performs a specific action, a specific task. It's essentially a user with a job description, whether that job description is super specific to read mailbox or whether it's extensive to the point of, you know, you are going to do a full-blown deployment lifecycle, and I need you to make sure that that is the outcome. Where I don't necessarily see it as different, but obviously the controls themselves and the limitations are different, because I guess I really wanted to not push a Microsoft-y approach, but the platform that you manage identity for agentic AI is the same platform that you manage users in. It's the same conditional access, which is the locked front door to make sure you can get in. Agentic AI is now being associated to even having the ability to use things. There's a front door that is applied to users the same way that it's applied to agentic AI. And I'd say that it's not necessarily that there is a difference between the controls. You would only give a user in your environment global admin if they were going to have the keys to the kingdom, and you put specific controls in place for that, so that they have to be using passwordless and they're not, you know, SMS for authentication. It's no different to, you know, having a least privilege mentality is how I would put agentic AI. I wouldn't say it's any different. It's just a different way of thinking about it.
So I've got a question: how we can secure our OPAs on-prem agents while patching them and updating them based on your conversation?
I think, yeah, once again, I got half of that one. So how can you secure your whilst being able to patch it and so I guess I would suggest that it's, I mean, it's hard to say the exact, like, obviously, I would almost suggest that it follows no different to, I guess, obviously I brought the analogy of a user for protecting. It would follow a standard application lifecycle in terms of what's being documented, how's it being updated, do you have a development, test, staging, production set of agents across the board. I'd almost suggest that we have frameworks in place that would help with that. It's just the context of, it's not necessarily a application, it would be an agent. So I did only get like half of the question, but I apologize if I missed a part of it. Yeah, so I guess Essential 8, you've got patching application, the ISM, and I'm not an ISM Bible, but ISM recommends that if there are any vulnerabilities that it is patched within, 48 hours. Do you have a platform in place that's scanning your NPM packages for when there is a vulnerability? Do you have that being logged back to a central system, which can be seen by a security team to raise an incident when that validation picks up a vulnerability? Obviously, agents themselves are a bit spread in that case, but I think having a centralized location to know every agent is different. I don't think your agent will ever be the same agent that's deployed in any other organization. And so there's obviously going to be a bit of a dynamic nature to that, but the controls around making sure that, you know, there's platforms that exist to be able to scan those, and are they being logged? Are they being, you know, triaged when something does come up? And then I guess applying an Essential 8 mindset is, I think, yeah, it's like 48 hours for vulnerabilities in like ML2. George,